So this is how you can accept inputs in your components. So properties or custom attributes, you could say, you can set on your own components to pass data into them. Now, earlier in this section, I showed you an alternative way of managing state, so of managing data that may change over time and where those changes should then be reflected in the UI. And that alternative, modern approach offered by Angular works with so-called signals. Now, it turns out that you can also use signals for accepting inputs, instead of using this add-input decorator. And therefore, I also want to introduce you to how you would accept inputs with signals so that you do know about both approaches. And of course, you'll then also see both approaches in action throughout this course. Now, to accept an input as a signal, you start by importing the input function from @Angular core. Input with a lowercase I, that's important. With an uppercase, it's that decorator. With a lowercase, it's a special function. Now, with that imported, you can then replace these inputs here by still adding properties with the intended names, like avatar, as we did it before. But instead of adding a decorator in front of them, you now assign a value, an initial value, to these properties, and that value is the result of calling that input function. That internally tells Angular that this avatar property should be an input to this component, so that it should be settable as an attribute when that component is used. Now, that's not all you typically do with that input function though. Instead, you can also assign a default value, which will be assumed if no input value has been received yet, which could, for example, be an empty string. Alternatively, you can also not pass an initial value, and therefore the initial value would be undefined, but you can tell TypeScript in the end, and therefore implicitly, of course, also Angular, that eventually a value of a different type will be received. For example, here, that eventually a string will be received by adding angle brackets after this input function name, but before the parentheses. And between those angle brackets, you can set the type of value that will eventually be received by that input. Now, this angle bracket syntax here is not some Angular specific syntax. Instead, that's a TypeScript thing. It's a so-called generic type we're dealing with here. Input, the input function, is a generic function set up to be generic by the Angular team, which in the end means it's a function that's able to work with a broad variety of value types, a broad variety of input value types in this case here. And with that angle bracket syntax, we simply tell TypeScript which kind of value will eventually be received by that input. And that then can help us further down the road when we work with that input value. So when we work with this avatar property, because TypeScript then will know that this avatar property will hold a signal in the end, since this input function produces a signal, so a data container, but inside of that data container we'll eventually have a string value. That's the idea behind this syntax, and you'll see it from time to time when working with TypeScript, not just in Angular projects. You can also mark an input as required by calling input.required, so a modified version of that function, so to say. That's the equivalent of setting required with the add-input decorator. Now, when using required, you can't pass an initial value. As you see, I'm getting an error here, because if this input is required, you're telling Angular that it will be set, so an initial value, of course, makes no sense, because there will be a value set from outside of this component anyways. So in that case, you should just tell Angular which kind of value will be set here by using this angle bracket syntax again. And then we could do the same thing with the name input here, with name input required, which will also be a string, like this. And that's simply an alternative way of accepting inputs instead of using this decorator approach. Now, what's really important to understand and keep in mind when setting up inputs like this as signal inputs is that from outside this component, so in this case from inside the app component, you still use them like before. You still set those inputs with this syntax. So by setting the properties that are marked as inputs as attributes, you could say, on your custom elements. You can still use data binding, property binding to set them to a dynamic value, and that value here also doesn't have to be a signal. Indeed, here in my application, in the app component, this users array is a normal array. It's not wrapped in a signal or anything like that. So I'm passing a non-signal value as a value to this input signal. And that's really important to understand that from outside this component, it doesn't matter whether your inputs are set up with that input decorator or this input function. Now, one advantage we can already see inside of this function, where we are using input though, is that we, for example, no longer need that exclamation mark, because we're now no longer setting up a property which technically doesn't have an initial value, as it was the case here, but instead now, from a technical point of view, the avatar and name properties do have values assigned to them. They do have these input signal objects assigned to them, which then will, as you learned, internally hold some other value since they act as data containers, and those internal values will be the actual input values. But that's still one nice thing to have, that we no longer need to convince TypeScript that we will have values here, simply because this code here works in a different way. Well, and since avatar and name now are signals, we can and should now also use them as signals. So in the user component template file, for example, you now must execute name as a function, since that's how you read signal values and how you get Angular to set up that behind the scenes subscription, which does allow it to efficiently update the UI. And we should also change this code here where we calculate the image path. Instead of doing it like this with a getter, we can and should now do it with help of the computed function. So image path should be a computed value, which is created with help of that computed function that's imported from @AngularCore, about which you also learned earlier in this section. And this function, as you learned, takes a function as an input, and that function returns the computed value, but we may and typically will now use a signal in there, and we should therefore also call it, because that's always how you read signal values. But since I'm now using computed, Angular will only recompute this image path value whenever this avatar value here changed. So it's more efficient than what we had before, where the scatter would be called whenever anything happens to this component, for example. So that's another adjustment we should make when using these signal inputs. Now, with that adjustment made, image path is now also a signal, a computed signal, or a signal that's created with help of computed, and therefore in the user component HTML file, you now also must execute image path as a function to read that signal value and set up that behind the scenes subscription. Now, what's worth noting here is that these input signals, however, are read-only signals, which means they in the end only change or only get new values if the input value outside of this user component changes. So if we would do something here in that app component that would change the value set on one of those properties, and you will soon see how you could change a value here, then that new value would be received in the user component, but you can't change the value from inside the user component. So if here inside of this onSelectUser method, I would decide that I want to change the avatar value, I can't do this. If I try to call set on this avatar signal here, you see I'm getting an error that this does not exist on that input signal. And you might recall that earlier in the course, when I introduced you to signals, you were able to call the set method to set a signal to a new value. Now, it does not work here for these input signals because, as I just explained, they are read-only, so they can't be changed from inside the component where the inputs are registered. That's just also something to keep in mind. Now, the obvious question, of course, therefore, is why you would use these inputs here, or why you would use the older decorator-based approach without signals. Well, and the answer is the same as before when I introduced you to signals. When working with signals, and therefore also when working with signal inputs, you get this advantage that Angular manages these behind-the-scenes subscriptions and that Angular is able to efficiently update the parts of the UI or the values in your code that need updating when such a signal-based value changes. So it can be more efficient depending on the rest of your application and so on. Now, this efficiency might not always matter because the other, older approach without signals is also pretty efficient. But even more importantly, this signal feature and also these signal inputs are a relatively new Angular feature, and therefore many Angular projects out there, actually the majority of Angular projects out there, especially in big companies, do not use signals yet, or not necessarily use them in the entire code base. Therefore, you will definitely encounter lots of code bases and lots of demos and so on that do not use signals and that do instead use the input decorator for accepting component inputs, which is why you should know about both approaches, and which is actually why I will not continue with the signals here, why I will delete that code, and why I instead will go back to this decorator-based non-signal approach, which also means that in the template I no longer call these values as functions. You could use signals, you could use the input function, but for the reasons mentioned, because you'll see plenty of projects that do not use those signals, I'll stick to this code for now. Of course, throughout this course, you will see plenty of signal usage though, because I want to teach you both. And now you do know about both ways of accepting component inputs, and both ways are important to know.